In this section, we'll learn a way to tell overfitting, underfitting, and a good model. So here we have our data 3 times. Our data seems to be well split by a quadratic equation of degree 2. So we're going to try and fit 3 models. The first one, a linear or degree 1 model, which doesn't do a very good job since it underfits. So it's a high bias model. The second one, a quadratic model of degree 2, which is just right. And the third one, a higher degree polynomial of degree 6, which overfits, so it's a high variance model. Now we'll draw some curves that will be able to tell these models apart. So let's start here with the high bias linear model. We're going to start training the model with very few points and increase the number of points gradually. So if we train this model with, say, 4 points, we can do a pretty good job fitting the training set. So we have a tiny training error, which we'll plot in the graph in the right. But once we evaluate it on the cross-validation data, well, since we have trained the model on only 4 points, it cannot be a very good model, so it probably has a pretty high cross-validation error. We won't show the cross-validation set, but you can pretty much imagine any other random subset of this data. So we plot the cross-validation error over here. And now we increase to 8 points and we train a linear model again. The training error may increase a bit since it's harder to fit 8 points than 4. But since we have a slightly better model and we've used more data to train it, then maybe the cross-validation error has decreased a bit. But not much since it's a linear model trying to fit quadratic data. So here are the training and cross-validation errors in the graph. And now we increase to 12 points and we train the model again. So once more, the training error may increase a bit since there's more training data to fit. But the cross-validation error will also decrease a bit since we have a better model trained with more data. But it still won't decrease by much. It seems that as we increase the number of points more and more, the training error will keep increasing and the testing error will keep decreasing. So if we draw these two curves, they'll get closer and closer to each other and maybe converge at some point. The point they converge should be high anyway, since we don't expect these models to have small error as they are underfitting. Now let's do the exact same thing with the quadratic model, so let's remember that this is the good model. So training with 4 points, just as before, we can do pretty well in the training set, so we have a small training error. But since we trained the model in very few points, we probably didn't do very well in the cross-validation set, so our cross-validation error is large. Now if we increase to 8 points, again, our training error increases since we have more points to fit. But since our model knows more, as it's trained on more points, then the cross-validation error has decreased. And if we go to 12 points, the same thing happens again. Training error increases, cross-validation error decreases. So as before, these curves get closer and closer to each other, except now they converge to a lower point since the model is good and we expect it to have small error. And finally, let's do the same thing with the degree 6 model. Let's remember that this is the model that overfits. So let's train with 4 points. Again, we can fit 4 points very easily, so we have a small training error. And again, as we don't have very much information in 4 points, this model probably didn't do very well in the cross-validation set, so we have a large cross-validation error. Now, if we increase the training set to 8 points, we have a slightly larger training error and a slightly smaller testing error, just like before. Now, if we increase the training set to 8 points, then we have a slightly larger training error and a slightly smaller cross-validation error. And this happens again for 12 points as we've seen before. But now something interesting happens. The training error will never grow too large since models that overfit tend to do very well in the training set as they can fit it very well. And the cross-validation error will never get too low since, as we've seen, models that overfit do not do very well in the cross-validation set. So as we increase the number of points, these two curves will get closer but will not converge to the same point. There will always be a distance between them. So in summary, here we have our 3 models, the high bias, the good one, and the high variance. And in the high bias or underfitting model, the curves get close to each other and converge to a high point. In the good model, the curves again go close to each other and converge to a low point. And in the high variance or overfitting model, the curves do not get close to each other. The training one stays low and the cross-validation one stays high. So this is a way to tell between underfitting, overfitting, and just right. We just look at the learning curves and see what shape they form.